So when you see these equations in this section, what you need to do is know what type of problem you are dealing with. In all four of these problems here, they are all related because notice the variables in the exponent. Because the variables in the exponent, that instantly makes them an exponential equation for our purposes. They also have another relationship which we'll get to in a second. In all four parts here, we're going to use the one-to-one property, which says that for B positive, I'm summarizing here with the one-to-one property. For B positive, B not equal to 1, B to the M equals B to the N, if and only if M equals N. Now that's very mathy, but what that says from left to right is that if you can write both sides as the same base, then all you do is you set the exponents to be equal. So in part A here, notice 81 is the same thing as 3 to the 4th. So we are able to write both sides of the same base as 3, which means, according to the one-to-one property, the exponents must be the same. Well, our goal was to solve for the variable x, and notice in part A, we have the variable all by itself, x equals 4. Done. So all four of these problems on the screen are related because they're exponential equations, 1, and the first subclass is that they're one-to-one exponential equations because we can write both sides as the same base. It's about powers. Keep that in mind. So in part B, the same base would be 4. So we can write 16 as 4 squared. So because of the one-to-one property, since we now have the same base, we only concern ourselves with the exponent. The exponent on the left must equal the exponent on the right. Solving for x, we get 2x equals 3, and that implies x equals 3/2. In part C, what's our common base? Hopefully you said 3. Notice 9 is 3 squared, but that 9 was already to a power. So notice the use of the parentheses. Because of our exponential rules, we know if we have a power to a power, we multiply the powers. Be careful. Since you are multiplying one term times two terms, you have to distribute. So don't write 4x plus 1, it's 4x plus 2, because you distributed that 2 through right here. Even though it's not written, it's implied that there's a 1 here. So you would say 4x plus 2 equals 1. And to solve for x, we're going to subtract 2, divide by 4. We get negative 1/4. Lastly, in part D, we need a common base. What's that common base going to be? Hopefully you did not say 8. Again, it's about powers, not multiples. 16 is a multiple of 8, so that's not going to help us. 16 is not an easy power of 8. But 16 and 8 both have a common power, that being 2. 16 is 2 to the 4th. 8 is 2 cubed. Again, just like previous problem, we have parentheses because we have a power to a power. When you have a power to a power, again, you multiply the powers. So the left-hand side is really 2 to the 4x plus 4. And the right-hand side is really 2 to the 9x minus 9. Since the bases are the same, we now set the exponents to be the same. 4x plus 4 equals 9x minus 9. Bringing the 4x to the right, bringing the 9 to the left, we get 13 equals 5x, or x is 13/5. So again, all four problems on the slide are exponential equations because the variable is in the exponent, and we were able to write both sides as a common base. So according to the one-to-one property, we set the exponents to be equal.